This is the final build. It looks pretty nice, but you know, there is an issue. As I said before, this power supply is so short that it doesn't make it up to the lip here, and that DIN rail, really you should put some kind of spacer underneath it, a couple washers. You'll need a little bit longer screw to get it up flush. I had this DIN mount cabinet, but I didn't have the bottom to it, and so I just cut it off, and I'm just using this as a front panel. You could go in there with a flat piece of plastic or piece of metal. I just used double foam tape to attach it to this flat surface on the underneath. And what I have is this LED lights up anytime the sense resistors over here are receiving power. And this little switch is like a summer-winter arrangement, and let me show you what that is. And this is a pot you can adjust. You don't need any of this. I think you should keep it as simple as possible at first with just a resistor. Get the thing to work and use the power supply to adjust the voltage to set the array power point. But here's what I've done. I have a LED in series, and that will drop the voltage 1.7 volts for a red. They're all between 1.7 and about 2.3 volts, depending on what color you use. For the summer winter, you know, I put this switch in there. If you're doing diversion, this could be for being more aggressive, so you're harvesting power. But if you had a relay attached to your battery, and when the battery was near full, then you'd know you could be more aggressive in heating water, and so you drop the voltage, so you divert more. Basically I get this little calculation here. The voltage differential with temperature, just from memory, it's about 0.25% per degree C. And so if we had, this could be up to about, 0.4. Look on your data sheets, it'll tell you. And, if we had a 16 degree C change, remember that most panels will reach a terminal temperature. They'll dissipate heat. The hotter they get, the more they dissipate heat. And so for summer, it pretty much stays about the same temperature when it's in sun. And so I had 60 volts here. So it comes out to about 2.4 volts. And that comes up to 1.7 volts for a red LED. And just any silicon diode, put that in series, you'll get about 2.4 volts. Again, you can calculate it out. Probably just easier to put in a pot. The pot, you want to be about 20% of your total resistance. This Zener here, this provides some extra margin for startup. So if you were using a Zener system, the nice thing about using a switching power supply, I use a lot of these. These cost me about 75 cents, but I buy 2 dozen of them at a time. And this thing starts working at about 20 volts. And so it's not providing any voltage at all. And then snap, it'll produce the 12 volts. And so you don't have to worry about this gradual startup, because your FETs, you don't want to drive them with anything below 9 volts. That'll put them in a linear region and they'll overheat. So it's nice to use the switching power supply, but these can be damaged by lightning. If you just have a resistive drop into some Zeners, that gives you the highest immunity from lightning. Always use a couple resistors in series. That protects you from flashover with an arc. It also allows you to distribute the heat amongst more resistors. And so you can use really small resistors, even eighth watt resistors, if you have a number of them in series. And when you have two Zeners like this, you'll want to have a little bleed resistor to make sure that this reference voltage that's the voltage right here that it looks at, that this comes up before this voltage, and that prevents a turn on when the voltage is really too low. Like I say, that's more for advanced. I tried to keep this as simple as possible. You just had a couple resistors, the power supply provided the voltage, you didn't have to worry about it. It wasn't an extra thing that could ruin the project if you did it wrong. You didn't have to do any calculations, and all you had was this 2 op amps, and this was the simplest thing you could do. And remember, put some test points out. If you have a circuit board like this, and you can get a really big circuit board such that you can really spread things out and it's much easier to visually see. You got your voltage divider, you got your reference, and you got the drive to a FET. And you can use a smaller FET or a big FET, but basically if it's this is a 50 amp FET, don't go over 5 amps with it, and then you won't have any massive heatsink you'll need. And if you're doing 10 amps, do 2 in parallel or 3. All you need to do is drive each one with a 330 ohm resistor and just put them all in parallel. And I point this out is if you really want to have the thermostat. If you have a nice little electronic thermostat or even a mechanical one, you can put it right here between the PV voltage and the voltage that goes to the switching power supply and to the sense resistor. You can put that there. You don't have to worry about the contacts or any voltage on it. But if you really wanted to make a break, if you're under 120 volts, the PV will be, if you open this up, that PV will go to open circuit voltage. And this side, because it's a shunt regulator and it's being fed by a resistor, this stays at your set power point. The heater power goes down dramatically, but the difference in voltage between open circuit and the power point voltage, generally that'll be pretty low and it'll stay under 30 volts. And for a little extra measure, I put a small capacitor on this side, so when this opens up, this voltage isn't going to immediately jump up. It's going to rise up slowly and give this switch enough time to get some distance. But as I showed before, I had a 270 ohm resistor in between the panels and the controller, and the thing worked fine. And the nice thing about putting a little bit of load on it is that your water tank is always going to be losing some power, some heat, and you'll have to replace that with power. So if you can just feed 10, 20 watts into your water heater, that'll maintain the temperature instead of letting it just continuously drop down and then turn back on again. And that little bit of load will also drag down the open circuit voltage on the panels. So that's kind of a win-win in that situation. But I have one of my water heaters operating in this manner, and it works out fine. But again, if you want to have a voltage reference, you can use some LEDs just with a, you have a 13 volt Zener to get that voltage right. And 3 red LEDs in series will give you about 6 volts. You just need something about 5 or 6 volts for a reference for the op amp comparator. But like, put some test points on it. You want to measure what your power is, you want to measure what your sense voltage is, and you want to measure what the reference voltage is. That's the only 3 voltages you need to know. And as I showed you before, you can take any old little speaker, put a 0.1, 0.2 microfarad capacitor in series with it, attach that onto the output, across the output of the heater or across the FET, and it'll produce a tone, and you can adjust things up, and if you hear it buzzing, you know it's working. And when you have a DIN situation, I picked up these little DIN adapters here, and I drilled some holes in it, like you could hold this one capacitor. You got enough room to stack 2 capacitors on top, put them in parallel, as long as you do some glue before you try the tie wraps. That works out well. One of my prior videos, I did a piece of wood where I drilled holes and I could put the capacitors in, hot melt glue, and I did a cross cut so the wires could connect onto this. It made, painted up and made kind of an attractive capacitor bank. But like I said, the more capacitors the better. You want to get a very low ESR, and you want to keep the current down on a capacitor, because internally this post going down is welded to the foil, and those welds, they make these things fast. They do spot welds. When you start doing really big pulses, if you have any kind of weak welds, it'll bust them open, and then your capacitor won't work anymore. But most capacitors, consumer grade capacitors, are only good for about an amp. This was a specialty capacitor for a switching power supply. This is a little over 3 amps. So, you don't try and start a car with a 9-volt battery. You need to have a sufficient number of capacitors to really handle high currents. And if you do that, these will run for years and never fail.